This is the problem that we are going to do now. Now see, in this problem, on the left hand side you have a tan inverse, right? And on the right hand side you have got a cos inverse. That means clearly the problem where you simply have to convert a tan inverse to a cos inverse, right? And how do you convert a tan inverse to a cos inverse? You take tan inverse of whatever is given to you, as theta. Okay. So therefore, what you get? You get tan theta is equal to 1 by root 3 tan x by 2, right? Now, since you want to convert tan inverse to a cos inverse, what is the multiple angle relation between tan and cos? What is the multiple angle relation between tan and cos? Tan square theta is equal to 1 minus
1 minus cos 2 theta by 1 plus cos 2 theta.
1 minus, but we want cos inverse. So we'll write this in terms of cos inverse. Cos 2 theta, because we want it in terms of cos inverse. So cos 2 theta is equal to 1 minus tan square theta by 1 plus tan square. You all know this, right? From multiple angle formula. Yes. The formula that I was going to write, it actually comes from this formula. Whether you write cos 2 theta or whether you write tan square theta is equal to 1 minus cos 2 theta by 1 plus cos 2 theta. Okay, it's the same thing, because this formula here we get from this only. Okay, and vice versa also. So therefore, we are going to use cos 2 theta because we want right hand side, right? Because we see that the right hand side is in terms of cos inverse. Okay, so we will use cos 2 theta. Now we put the value of tan here. 1 minus 1 by root 3 tan x by 2 whole square divided by 1 plus 1 by root 3 tan x by 2 whole square. Okay, now we simplify this. So 1 minus 1/3 tan square x by 2 divided by 1 plus 1/3 tan square x by 2. Now you take the LCM in the numerator and the denominator to get 3 minus tan square x by 2 divided by 3 plus tan square x by 2. Okay. Now what you see here, that the right hand side here, if you see this expression, this is in terms of cos, but here we are getting in terms of tan, isn't it? So again, in place of tan square x by 2, what we do is we put it in terms of cos. That is, tan square x by 2 is what? 1 minus cos x, because this angle is x by 2. Tan square x by 2 is 1 minus cos x by 1 plus cos x. Yes, did you follow what I did?
Yes.
Okay, so now I'll take an LCM again. I get thrice 1 plus cos x minus 1 minus cos x divided by thrice 1 plus cos x plus 1 minus cos x. Okay, so now it's 3 plus 3 cos x minus 1 plus cos x divided by 3 plus 3 cos x plus 1 minus cos x. You simplify this, you get you get 2 plus 4 cos x in the numerator. In the denominator, you get 4 plus 2 cos x. Okay. Now what you can do is you can take 2 common. 1 plus 2 cos x divided by twice 2 plus cos x. So here 2 and 2 will cancel. So you simply get 1 plus 2 cos x by 2 plus cos x. Are we getting the right hand side? Yes, we are getting the right hand side. Right? So therefore, what have we got here? We have got cos 2 theta is equal to this. So therefore, what should be 2 theta? 2 theta is equal to cos inverse of this. 1 plus 2 cos x by 2 plus cos x. And therefore, what is theta? Half cos inverse 1 plus 2 cos x divided by 2 plus cos x. So what did we start with? We started with theta as tan inverse of this left hand side. And what did we end with? We ended with theta is equal to this on the right hand side. Hence, our given question, tan inverse of 1 by root 3 tan x by 2 is equal to half cos inverse 1 plus 2 cos x by 2 plus cos x. Clear? Or any question?
No.
Devanjan, have you done all this?
Yes, sir.
You've done. Very good. Let us move on to the next problem. The next problem here is prove that cot pi by 4 minus 2 cot inverse 3 is equal to 7. Okay. We'll start with the left hand side. Cot pi by 4 minus 2 cot inverse 3. First, we'll change this cot to a tan. Okay. If we change cot to a tan, it will simply become 1 by tan, isn't it? Pi by 4 minus 2 cot inverse 3. Yes. Next, we are going to use the compound angle formula for tan in the denominator. This is if you see here, this is 1 by tan a minus b form, right? We'll use that form, tan a minus tan b by 1 plus tan a tan b. We have tan pi by 4 minus tan, what is the angle here? 2 cot inverse 3 is the angle. Divided by 1 plus tan pi by 4 tan 2 cot inverse 3. Okay. The next step is you put the value of tan pi by 4. You get 1 minus tan 2 cot inverse 3 divided by 1 plus tan 2 cot inverse 3. Now see here, we are getting tan and cot inverse. So it would suit us to convert this cot inverse here to a tan. Okay, but let me just take the reciprocal first, then I'll convert. So if you want, if we can write this as 1 plus tan 2 cot inverse 3 divided by 1 minus tan 2 cot inverse 3. Okay. So this is 1 plus. Now you convert this cot inverse to a tan inverse. Tan 2 tan inverse. And when you are taking tan inverse, this becomes reciprocal. 2 tan inverse 1/3. Now clearly you see you have a tan and tan inverse, but the only problem here is with this 2. Okay, so we are going to use this. We are going to convert 2 tan inverse to a tan. How do you convert 2 tan inverse to a tan inverse? You know that 2 tan inverse x is equal to tan inverse 2 tan inverse x is equal to tan inverse 2x by 1 plus 1 minus x square, isn't it? This is what you know. You have done this, right? We are going to use this. So 2 tan inverse 1 plus tan of tan inverse 2 into 2x by 1 minus x square. Okay, divided by 1 minus tan, same thing here, 2x by 1 minus x square. Okay, now we simplify. 1 plus I'll just write the simplified this thing simplified what fraction that you are getting. Okay, you will get 1 plus tan of tan inverse 3 by 4. Okay, if you simplify this in the numerator, the fraction that you have in the curly brackets, that is what you're going to get. And here you're going to get 1 minus tan of tan inverse. You're going to get 3 by 4 here also. Okay, so now what happens? You simply get 1 plus 3 by 4 by 1 minus 3 by 4. Again, you take the LCM in the numerator and denominator, you'll get 7 is equal to your right hand side. Yes, any questions now?
No, sir.
Next problem. Next problem, this should be the second last problem. Question is prove that. Let us do these two. Let us do two problems together. Prove that. First part of this problem is sine 2 tan inverse 3 by 5 minus sine inverse 7 by 25 is equal to 304 divided by 425. And this was the first part. Second part is 2 tan inverse 1/5 plus cos inverse 7 by 5 root 2 plus 2 tan inverse 1/8 is equal to pi by 4. Now, both are ISC problems, okay? Both of these. Solution. We start with the first one and we start with the left hand side. First one. Left hand side is sine 2 tan inverse 3/5 minus sine inverse 7 by 20. Okay, now see, here within the sine, you have one tan inverse and you have one sine inverse, right? So it is always recommended that you change. You can hear me, all of you?
Yes, sir.
Um, it is always recommended that you change both to tan inverse. That means this sine inverse you change to tan inverse. Okay. So let us try and change this sine inverse to a tan inverse. How to change this sine inverse to a tan inverse? How do you remember this? You remember this formula that sine inverse of x is equal to tan inverse 2x by 1 plus x square. Sorry, sine inverse of x is equal to tan inverse of x by root 1 minus x square, right? Isn't it? Remember this? Or should I show you the conversion from sine theta and then cos theta? Which one? Tell me. Tell me which one.
Yes, sir.
Should I show you the conversion?
No, sir.
Okay. Let us write then directly. We write tan inverse then. Sine of 2 tan inverse 3 by 5 minus. Now this sine inverse, if we change to tan inverse, this will become 7 by 25 divided by root 1 minus 7 by 25 square, right? So I've changed both now to tan inverse. Okay. Also, what you can do is you can change this to tan inverse also. Let us change this to tan inverse to simply a tan inverse. How do you change? By multiple angle formula. You know that 2 tan inverse of x is equal to tan inverse 2x by 1 minus x square, isn't it? That is what we use here. Tan inverse, 2 tan inverse to a single tan inverse. So we get tan inverse 6 by 5 by 1 minus 3 by 5 square, right? Yeah, so that's it. Both have been converted to tan inverse. Okay, so now we'll simplify what is there within the brackets. Okay, so I'm not showing you the simplification. You'll simplify this. What is there within the brackets? You will get tan inverse 15 by 8. Okay, and here you will get tan inverse 7 by 24. Okay, next, this is not sine inverse, this is simply a sine. So this is sine of, now you have tan inverse x minus tan inverse y. So we'll apply that formula here, which is tan inverse of x minus y divided by 1 plus x y. Okay. Now we would like to simplify this, and once you simplify this, what you are going to get here is sine. The simplification will be a little laborious because you get a little big numbers here. You get sine tan inverse 3 by 4 by 297. Okay. But the problem is on the right hand side, what do you have to prove? You have to prove is equal to 3 by 4 by 225. That means this entire thing was supposed to be expressed in terms of tan inverse. But we have got what? Sine inverse, sorry. Because here we have a sine. If we can express this entire expression in terms of sine inverse, we'd easily get a number, isn't it? So therefore, but we are here getting sine of tan inverse. So we convert this tan inverse here to a sine inverse. Okay, how do you convert? I say let theta is equal to tan inverse 304 by 297. That means I get tan theta is equal to 304 by 297. Now you can draw a triangle and do it. Otherwise, if you don't want to draw a triangle, you can use this result. cosec square theta is equal to 1 plus cot square theta. So 1 plus, if tan theta is 3 by 4 by 297, cot theta would be just the reciprocal, which is 297 by 304 square. Okay. So now you find this, you simplify this, you will get 180625 divided by 304 square. This is what you are going to get. Deliberately, I have not squared 304 because I'll be taking the square root. That is why. So cosec theta will be equal to the square root of 180625 divided by 304 square. Now you can find out the square root of 180625 by division method. You can find this out to be 425 divided by, and 300 square root of 304 square is simply 304. That means what is sine theta? Sine theta is, that is just the reciprocal of this, 304 by 425. That means what is theta? Theta is the sine inverse of 304 by 425. Okay. So therefore, what have we got left hand side? Hence, what was left hand side we started with? We started with sine tan inverse 304 by 297. And we finished here with sine inverse sine of sine inverse 304 by 425. And therefore, which is equal to 304 by 425. And that was what was there on your right hand side? Right? You have to prove that this is equal to 304 by 425 here. This was what was there on the right hand side. Any questions on this problem? We'll do the second part now. Last problem from inverse trigonometric functions. And we'll start from the left hand side. The left hand side here is 2 tan inverse 1 by 5 plus cos inverse 7 by 5 root 2 plus 2 tan inverse 1/8. Okay. And if you see what is the right hand side that we need to prove here, we need to prove that this is equal to pi by 4, right? The left hand side we started here. We need to show that this left hand side here is equal to pi by 4. Okay, so we see that here I have a tan inverse and here also I have a tan inverse. And here also I have a 2, here also I have a 2. So what I do is I take these two tan inverses together, take 2 common and take these two tan inverses together. So I have 2 tan inverse 1 by 5 plus tan inverse 1 by 8 plus cos inverse 7 by 5 root. Okay. So this is 2. Now you can use your compound angle formula here. Tan inverse x plus tan inverse y. So this is tan inverse of x plus y divided by 1 minus x into y. Okay. Plus, now this is a cos inverse here. Okay. Now cos inverse, can we change to tan inverse? Can we change cos inverse to tan inverse? How do we change cos inverse to tan inverse? Yes, any idea? Do I have an audience?
Yes.
Tell me how to change cos inverse to a tan inverse.
Cos inverse to tan inverse. 1 minus tan square theta by 1 plus tan square theta. Cos
No,
theta.
there is no multiple here. So simply what we'll do is we can write cos inverse as tan inverse of sine is there. This will be root over of 1 minus 7 by 5 root 2 square.
7 by 5 root 2 square. Okay, sir.
divided by 7 by 5 root 2. You understood this step?
Yes, sir.
Understood how to convert cos inverse to a tan inverse?
Hmm.
Fine. So now what you do here is you simplify this, the first tan inverse. You simplify the first tan inverse to get 2 tan inverse 1/3. Okay. And you simplify this, the second, to get tan inverse 1/7. Okay. And now again you have a 2 tan inverse 1/3 here. So we are going to use this result. 2 tan inverse x, we are going to convert simply to a tan inverse x. We are going to use this result here. Okay. So tan inverse 2/3 by 1 minus 1/3 square. Okay. Plus tan inverse 1/7. Now again you simplify this. You will get tan inverse 3/4 plus you have tan inverse 1/7. Now again you use your compound angle formula here, tan inverse x plus tan inverse y, to get tan inverse of 3/4 plus 1/7 by 1 minus 3/4 into 1/7. Okay. So now you simplify this to get tan inverse 25 by 25, which is tan inverse 1. It is 5 by 4 is equal to right hand side. That is your answer. Now, before concluding this, if you have any problem with any step, then I can explain. Otherwise, if you are not able to get this step, then please take note of this. If you want to convert this cos inverse here to a tan inverse here, you can also do it this way. Let cos inverse 7 by 5 root 2 is equal to theta. That means we get cos theta is equal to 7 by 5 root 2. Okay, so therefore what should be sin theta? It should be root over of 1 minus 7 by root 1 minus cos square, isn't it? This.
Yes, sir.
So therefore what is tan theta? Tan theta is sin theta by cos theta,
Cos theta.
which is root over of 1 minus
1
7
minus
by
7 to 2 whole square
divided
by
by 7
7
by
by
5.
5.
And therefore what is theta here? Theta will be tan inverse of root 1 minus 7 by 5 root 2 square divided by 7 by 5 root 2. Clear with this? If you are not able to do this directly, you can attempt this, but not in rough. Okay,
Yes.
you can take theta of phi is equal to cos inverse just below, and then again you start from the left hand side. Is it absolutely clear? Yes.
Yes,
Yes, sir.
sir.
Okay, so I'll stop here.